Hi guys, welcome back to Tech Tricks Info. Today let's learn about Otto cycle with the help of an animation over here as it's happening over here. So it's a pressure volume graph and also the piston movements will be taught over here. So the theoretical concept and the practical concept has a PV diagram, the pressure volume graph. Volume is in x-axis and pressure is in y-axis. So in theoretical concept we believe that the cylinder is full of air, which is practically not possible. So in practical concept, there is an air intake process happening from 1 to 2. Initially, the piston will be in top dead center and it gradually moves towards the bottom dead center as the air intake process progresses. So you can see the piston moving down and the air intake process is progressing from 1 to 2. In the second stage, you can see in the theoretical concept, adiabatic compression of air is happening because piston moves from bottom dead center towards the top dead center. See, it happens over here. So adiabatic compression means there is no heat transfer is involved. Theoretically we can say that, but practically definitely there will be a heat transfer happening. That's happening from 2 to 3. A compression is happening, but it also involves a heat transfer. So it is not an adiabatic process in the practical concept. So the piston moves from BDC towards TDC as the second stage completes. And the third stage, you can see that a constant volume combustion is happening from 2 towards 3 and the piston will be at top dead center. So here you can see in the practical concept the graph moves from 3 towards 4 like this, and it's a constant volume combustion in theoretical concept and it is just a combustion in practical concept. Here you can see that this straight line is going directly towards the volume and the volume is constant. That's why it's called a constant volume combustion. It's also called as an isometric process. Constant volume processes are called as isometric process, but here it's not a constant volume process. You can see how it waves from 3 to 4 in the practical concept. So at the end of that stroke, the piston will be at top dead center. Now here we can see that the other stroke uh, is an adiabatic expansion of air where the piston moves from top dead center towards the bottom dead center. So 3 to 4 adiabatic expansion of air. That means there is no heat transfer involved in the theoretical concept, but in the practical concept there is heat transfer involved. That is expansion of air happening from 4 towards 5 and the piston moves down towards the BDC. So that's the end of that stroke. Now the last and final stroke, which is the exhaust stroke. Now the piston moves from bottom dead center towards the top dead center for the exhaust stroke to happen. So from 4 to 1 the exhaust is progressing. You can see in the practical concept from 5 towards 1 the exhaust is progressing and exhaust ends from 4 to 1 in the theoretical concept and in 5 towards 1 in the practical concept. You can see the piston movement. We can reverse it and see it once again. From bottom dead center the piston moves towards the top dead center. So that's the theoretical and the practical concept of an Otto cycle is happening. It is in a petrol engine of spark ignition engines. I believe you learned this topic. So for more updates you can click the subscribe button so that you will get daily updates. You can also like our Facebook page or click the like button or do share. Be sure that you post your comment for any doubts and also to motivate us. Thanks for watching. Have a great day.